What's up, Stone Squads? Today we're going to talk about factoring. Factoring is probably the most important concept you can probably get out of Algebra 1. So we're going to talk about GCF. That's the first step in factoring. Is there GCF? But what is GCF? It's the greatest common factor. So our goal is to figure out, does all the terms, and that's the key part, is all the terms needs to have a common factor, the greatest common factor, and that's what we're going to factor out. Factoring means just breaking it up into pieces. Usually, like in a quadratic, we're going to have terms added and subtract together. Once we break it up into pieces, it ends up becoming like a multiplication problem. This is important when we talk about finding x-intercepts for any function. So this is important because this is universal for every function, not just quadratics, but any other functions out there. So when we start learning in Algebra 2 and so forth. So let's take an example first of what is a GCF? I give you 2x, 4x squared, and then x to the fourth. Alright, so my greatest common factor. So if you have 2, 4, x to the fourth, well, the first thing is we have to look at our numbers. That's a 1 here. So 1, 2, and 4, is there a common factor that they have? They actually do not. It's actually 1, so we're not going to touch that. But if you look at x squared, and x fourth, well, we could break it up, right? X, we have this 1x. X squared, we have 2x. X fourth, we have 4x's. So then what do they have in common? What they have in common is that 1x. So my GCF for 2x, 4x squared, and 1x fourth will be x. So x is my GCF. Alright, questions on that? Okay, let's try a couple more problems. Let's just do numbers, strictly stick with numbers. If I have 4, 8, 16. If I have 4, 8, and 16, what is my GCF? Well, 4 is just 4. 8, it's 4 times 2. 16, it's 4 times 4, or we could say 4 times 2 times 2. I'll break this up. So what is my greatest common factor? It's going to be this 4. They all have a 4 in common. That's the biggest one. So 4 is my GCF. When we talk about variables, the shortcut, I'm going to show you a little shortcut. The shortcut is to look at all your terms, and then the smallest exponent will be your greatest common factor. So in this case, it's x squared. Why? Because x squared, we always want to know the y's. X squared is x times x cubed is x times x. X fourth is x times x times x times x. So how many do they have in common? They have 2 in common. So we can just always take the smallest one out of all 3. But make sure it's for all. It's all or nothing. We can't just take it out of 2 or 3 of them. We're going to take it out of all the terms that are in your function. So with that, last example, now let's turn it into a function, x squared plus 4x fourth. Right now, if we wrote it differently, it should be to the 4th power. It should be your leading term, but it's okay, we can do it this way. What is my GCF? We're going to factor this guy. So my GCF, well, we have 1 and 4, so 1's my GCF there, and x squared, x fourth. Remember, it's the smallest exponent, so it's x squared. If I take out an x squared, our goal is to divide. Whatever we take out, we're going to divide by our GCF. So when we're dividing same bases, our rule was what? Subtract the exponent. So this cancels out. So you have 1. We're still left with the 4. 4 minus 2 is 2, so you have x squared. That is my GCF. Factoring just means backwards distribution property. So the cool thing about this is we can always check it by distributing this. So you have x squared plus 4x squared to the fourth. And does that equal this guy? That's how you check it. So I always have my kids check their answers for extra credit usually, but it helps them so they have the peace of mind that they did it correctly, and they always got the extra credit as well. So So that's GCF. That concludes our lesson. We're going to have 3 practice problems, and let's just get ready for that. All right, our basic problem, intermediate and advanced. We'll start with our basic. Our basic is, if I give you all these terms, that's a 4. Let's rewrite this a little bit so you guys can see it better. It's 4x to the 4th, 8x cubed, 12x squared. What is my GCF? Try to think about what is my greatest common. Common is a keyword, and then factor is a keyword, but we want the greatest one out of them. We don't want the least. So I'll give you about a minute. Try your best. Go. All right, let's try this out. Our goal is to try it. If you get it wrong, that is okay. Our goal is to keep practicing. You'll have 2 more practice problems after this. So slowly and gradually we'll get there. So let's look at our numbers first. 4, 8, 12. Where they all have in common, that's the greatest. They have a 4 in common. And x4, x cubed, x squared. Remember, what was a trick? Take the smallest out of the 3. So we take x squared. That is my GCF. 4x squared is my GCF. GCF is important because that's always your first step when we factor. So the first step is always important. All right, check your answers. Some of you guys might have put 2 here. That is a common factor, but it's not the greatest. So just double check all that, okay? Let's try our intermediate problem. If I gave you this problem, all I want you to do is factor out the GCF. Remember, when you factor it out, you want to divide each one by it. It is backwards distribution. So leave something, take out the GCF and leave whatever is left over inside. I'm going to give you about a minute for this one. Try your best. Like I said, we will get there. We just need to practice it. I'm going to give you about a minute. Go. All right, let's check it out. So what is my GCF? Let's start with my number, 3, 9, 18. They all have a 3 in common, right? 3 has 3, 9 has 3 times 3, 18 has what? 3 times 6, 3 times 3 times 2. So what do they have in common? They have a 3 in common. That's my GCF there. X cubed, x squared, x to the 1 power. What's the smallest one? Is going to be 1. That means means different pen. We're going to divide everything by our GCF. So 3x here, 3x there, 3x there. So what's left over if I do that? Well, 3 and the 3 cancels out. X cubed, x1 is x squared. 9 and the 3, that becomes 3. Subtract 2 and 1, you get 1. And the last one, we get what? 6. And then the x1 and the x1 cancels out. If you have 1x on top, 1x on the bottom, cancel them out, you're left with 0. So this is factoring out GCF. We can technically go one more step here. It is a trinomial quadratic. We can go one more step, but right now we're just practicing just taking out the GCF. Our last problem, our advanced level problem, is factoring out everything and solving it. We want to solve. So let's take this example here. My goal is to factor it out. Factor everything out. Don't stop just at GCF. Do your trinomials. It is equal to 0. Our goal is to find our x-intercepts. So let's find that. Set each one equal to 0. Give you 1 minute. Go. All right, let's try this out. 2, 4, and 16. 2 is my GCF. X cubed, x squared, x1. X is my GCF there. What's left over? X squared minus 2x minus 8. We get that. So the first step was to divide everything by 2x. Okay, now we can factor this guy. Let's factor this guy. You can use guess or check, X method. Multiples of 8, that adds up to 2. You have 2 and 4. Minus plus. So 2 times negative 4 is negative 8. Negative 4 plus 2 is negative 2. And then now what happens, because we factored is all the multiplication problem, we can use a zero product property, which is anything times 0, 0, right? Anything times 0, 0. So this guy, it could equal 0, this guy is equal to 0, that guy is equal to 0. So you have 2x equals 0. I like to write it out, show my steps. A lot of kids like to memorize just opposite. That doesn't always work. It works well when the a value is 1. The term's in front of the x, but the term in front of the x is a different number. If you go that route, it changes the problem. So I like to set it up like this, and then you say 0, -2, and then +4. So these are my x-intercepts if you solve this by factoring. So our first step was GCF, so that's important. And then we had this guy, this trinomial. We factored that guy, we got that, and because we're solving for my x-intercepts, by letting y equal 0, we're able to set that as an equation and then solve for that. So that concludes our lesson. Hopefully these 3 problems helped you. Please subscribe to my channel, please turn on notification, and let's get ready for some more videos. Thank you.